All right, the last example gives us a set of rules we need to follow. It asks, what are the horizontal asymptotes for the following rational functions? So we've got three cases here, and I'm going to discuss each one by describing the rule first and then showing you how it works in the problem. So in problem A, the only thing that's important is the leading terms. So the only thing I'm going to look at here is this 2x and this x. I'm not going to look at that minus 3 at all. It has no bearing on our horizontal asymptote. So the rule here is that if the leading terms have the same degree or the same exponent on the numerator and the denominator, then we're going to use the ratio of the leading coefficients. All right, so what that means is that if we have the same exponent on our leading terms, which we do, the leading exponent here is a 1, the leading exponent here is also a 1. You can't see them, but that means that the exponent is 1, because anything to the first power is itself. That just means you're multiplying it by itself a single time, not even squared, so it's just like 2 to the first power is 2, 4 to the first power is 4, and so on. The other piece here is that because they have the same exponent, we're going to take a ratio of the leading coefficients. The leading coefficients is going to be the number in front of the variable on both. Again, you can't see the one on the bottom, which means that it's a 1. So the ratio of the leading coefficients means 2 over 1. And 2 over 1 is equal to 2. So this has a horizontal asymptote at y equals 2. And it's that simple. Horizontal asymptote is at y equals 2. You don't really have to think too hard about that. B is a little bit different. If we look at B, we see that the leading exponents aren't the same on this one. This one has a 1, and this one has a 2. So the one on the bottom is bigger. So if there is a larger degree or a larger exponent in the denominator, the horizontal asymptote is always at y equals 0. Always, 100% of the time. So here, the leading exponent is larger on the bottom, so my horizontal asymptote is at y equals 0. I don't have to think about it. The exponent on the bottom is larger, so it's always going to be y equals 0. 100% of the time. Never changes. The logic behind this is because this being squared means that the bottom, the denominator of our function, is going to grow at a much faster pace than the top. So as the number on the bottom gets bigger, the whole thing tends to 0. As you divide numbers by larger and larger numbers, you get closer to 0. For instance, 1 divided by 2 is 0.5, but 1 divided by 3 is 0.33, and 1 divided by 4 is 0.25. So as the number on the bottom increases, the number on as a whole gets closer and closer to 0. So your horizontal asymptote states that your graph is going to tend towards 0, is all that means. And on C, we notice that the exponent is actually larger on the top. Again, the exponent on the top is 2, the exponent on the bottom is 1, so that means that the exponent on the top is larger. So if we have a larger degree or larger exponent in the numerator, there is no horizontal asymptote. So here, because it's larger on the top, we can just write no horizontal asymptote. Okay. What that means for us is that the number on the top now is going to grow much larger at a much faster rate than the number on the bottom. And if you divide large numbers by smaller numbers, your number is still going to get bigger as those numbers increase. So it's going to go on and on and on, and it may grow at a slower pace than if you weren't dividing it, but it will go to infinity. So your graph tends towards infinity, so there is no horizontal asymptote. And that's all that means.